Hey guys, this is Mr. H. Hey, I'm going to go over how to get the inverse of any function, and I'm going to use something a little different than what is traditionally taught. It's the same stuff, but I put a little twist on it, and I think the twist makes it a little easier for students to understand and be able to do. So I'm going to go through about 4 examples. So it's going to take me a little bit of time to get to those because I want to explain what I'm doing and why I'm doing it. All right, so let me just start. What you should see on the screen is this is one of my sons and my favorite movie, Spider-Man Into the Spider-Verse. So this is kind of homage to that movie, but it's also a play on words. I call my lesson today Into the Multiverse, and hopefully by the end of it, you'll understand why I'm saying multiverse. There's two kind of verses that we're going to be doing to find the inverse. We're going to be doing the inverse operation several times. So we're going to be doing multi-inverses, and we're also going to reverse the order. And when we do those verses, both of those types of verses, we should be able to come up with the inverse. So that's why I call it the multiverse. Now here's what I'm trying to do. I'm going to show you how to find the inverse of any function. And what you need to know, or what we're going to use, is basically PEMDAS. You remember that, parentheses, exponents, multiplication, division, addition, subtraction. I think most students are pretty comfortable with that. So we're going to be using that. And then, like as I mentioned, the other thing that we're going to do is we're going to take the inverse operations, and then we're going to reverse the order. And once we've done that, we'll have the inverse function. All right, so let me jump to this. Now, this is something that most students are familiar with. If you've never heard this, then hopefully you'll understand what we're doing here. It's basically an acronym. It says, please excuse my dear Aunt Sally. And the P stands for parentheses, the E stands for exponents, M stands for multiplication, D stands for division, A stands for addition, S stands for Sally. Now I'm going to change it up slightly. I'm going to say, please excuse Larry, my dear Aunt Sally. All right, so I'm going to put that in here. And the reason that I'm putting that in here is typically you're not taught logarithms until you get to high school. So, but logarithms are on the same level as exponents. So they should go there. So when we do PEMDAS now, it should actually have logarithms in there. So let me go through the hierarchy really quickly. First of all, parentheses always goes first. Now, sometimes the parentheses are implied. And I'll show you what I mean by that. The next level is exponents and logarithms. So those two are on the same level. So if you see those in an expression or an equation, you're going to do those second. The third thing that we're going to do is multiplication and division. Those are on the same level. So when we get to those, we're going to do those third. And then the final level is addition and subtraction. Those are both on the same level. We do those fourth or generally last. Okay. Now, I'm just going to go through a couple examples really quickly because I think it's good to kind of prime the pump, because we're going to be using these in order to find the inverses of functions. So first thing, the first couple are very simple. Everyone understands, most students understand that addition and subtraction are inverses of each other. That's why I have the arrow go in both directions. And +3, the inverse of +3 is subtracting 3, and vice versa. The next level is multiplication, division, and those are inverses of each other. So times 4, what's the opposite of timesing by 4? Dividing by 4. All right. Now, the next couple are the ones that sometimes give students trouble. And here's what I'd like to say for that. When the inverse of squaring something is taken the square root. So in this case, I have 10 squared. So the inverse of squaring 10 is to take the square root of 10. Okay. Now, Another example is cube. So if you cube something or take something to the third power, the inverse of that is taking the cube root or the third root of that. Okay, so in this example, I have 9 to the third power. The inverse of raising something to the third power is taking the third root of that third root. So whenever you're squaring, cubing, raising something to the fourth power, you're going to take the fourth root or whatever that is. So notice this is a 3, this is a 3, this is a 2, there's a 2 here as well. All right, now the last thing, exponents and logarithms. This by far is the one that trips a lot of students up. So whenever you see an exponential function, the inverse of an exponential function is a logarithmic function. So I've got these here. So exponents, the inverse is logarithms, the inverse of logarithms is exponent. So my example, I have 7 to the x power. So the base is 7 and the exponent is the variable x. Now the inverse of that is taking the log of x with a base of 7. So notice there's a 7 here, a base of 7, and there's a base in the log of 7, okay? So whatever the base is, that's what you're going to use for the logarithm. And if the logarithm has a base of 10, that's what you're going to use when you raise the exponent. So you have to focus on the base when you're doing the inverses here. All right, now that we've gone through that, we're ready. We're going to use PEMDAS. We're going to use these inverses, and then we're going to just reverse the order, and we're going to be good to go. Here's my first example. Let me get this set up. Okay, we're going to do number 2 here. Now, this is g of x equals 2x plus 8 divided by 3. Now, I said that sometimes there's implied parentheses. There is implied parentheses. When you see this kind of a stacked fraction, what this really means, let me make this a little thinner. What this really means is that this 2x plus 8 is technically in parentheses. So you're doing the 2x plus 8, you're doing the sum of that first, and then you're dividing that by 3. Okay, so I just want to make sure that's clear. So even though there's no parentheses there, there is an implied parenthesis. So that's why when we do PEMDAS, we're going to do it in this order. Now, here's the way that most students are traditionally taught. They're taught to get rid of the g of x, the function notation, and rewrite it with without the function notation. And then once you've done this, most students are taught to switch the x and the y. So what we're going to have here is 2y plus 8 divided by 3. All right. So now that we're here, we're going to use PEMDAS. So I'm going to put PEMDAS. So we're going to go in order. So the very first thing that we're doing to the y is we're multiplying it by 2 right here. So we say first thing we're doing is multiply by 2. The second thing that we're going to do is we're going to add that 8. So we're adding 8. And then the third thing that we're going to do is we're dividing by 3. Now, we're just going to do the inverses of those. The inverse of multiplying by 2 is divide by 2. The inverse of adding 8 is subtracting 8. The inverse of dividing by 3 is multiplying. I'm going to say multiply by 3. Now, okay, so we've got those. Those are pretty simple. Those are very simple. Now, we're just going to reverse the order. We're going to do this operation first. We're going to do this operation second, and we're going to do this operation third. So we just reverse the order. So we take the inverses, and now we're reversing. Now, here's the part that I think is easy. We already know when we get done, we're going to have y by itself. And we're starting with x on one side. So now all we're going to do is we're just going to perform these operations on that x. So the first thing we're going to do is we're going to multiply by 3. We're going to multiply x by 3. And then we're going to subtract 8. And then we're going to divide by 2, the whole thing by 2. And that's the inverse. So all we have to do now, is write the inverse notation. And we are done. That's it. That is the inverse. Pretty simple. Okay, now I'm going to do another example. This one's a little bit more involved. We've got a fifth root here. All right, so now, again, there is an implied parentheses inside the fifth root. So we're going to do what's inside the parentheses first. All right, so we're going to make this y equals the fifth root of x plus 2 plus 1. And then we're going to swap the x and the y. So this is going to be x equals the fifth root of y plus 2 plus 1. Now we're going to use PEMDAS. And the first thing that we're doing to the y is we're adding 2 right here. We're adding 2 to it. So we say we add 2. What's the next thing that we're doing? We're taking the fifth root of that sum. We're taking fifth root of y. So we're going to take the fifth root. Now I'm just going to write the fifth root symbol. I don't have to write anything inside. I just want you to know that we are taking the fifth root of y. And then the last thing we're going to do is we're basically adding 1. So we add 1. We're adding 1 to y. Now we're going to do the inverses. So the inverse of adding 2 is subtracting 2. The inverse of the fifth root is taking something to the fifth power. The inverse of adding 1 is subtracting 1. Now, this is why I like this. When you kind of break it out this way, it's easy to know what the inverses are. It's easy to know what you need to do. And it's also easy to know what the steps are. So we're going to do this first, this second, this third. Now, again, we know that when we get done, y should be by itself. And we're starting with x on one side. So we're just going to start doing these things to the x. So the very first thing we're going to do is subtract 1. Okay. And then we're going to raise that whole quantity to the fifth power. So we're going to do to the fifth power. And then we're just going to subtract 2 from that. And that is the inverse. We are finished. Well, we're almost finished. We just have to write the function notation. So I'm going to rewrite this minus 2. And that is our function, our inverse function. Now, again, you can check this. If you plug the function into the inverse, you should get x. What I'd prefer is that if you take an input and put it into g of x, you're going to get an output. And then you should take that output and put it into your inverse function, and you should get your starting input back. Okay. Hopefully that makes sense. If it doesn't, maybe I'll do an example for the end of this video is over. All right. So now so here's what I'd like for you guys to do now. So we're going to do another example. I want you to try this using PEMDAS, doing the inverses, and then doing the reverse, and see if you can come up with this. So stop the video, try it, and then come back and we'll work it together. Make sure we'll check it together. All right. Okay, so I hope that you've actually tried this, because it doesn't help if you just watch and you don't try. That's the only way that you get better at this. So let's go. First thing that we're doing, going to replace the g of x notation with y equals 2x plus 2 raised to the third power. All right, so now we are going to, I changed color so that you can see that we're swapping. We're going to swap the x and the y. So this is going to be 2 times y plus 2 raised to the third power. Now we're just going to use PEMDAS, which is pretty simple. We're going to start with the parentheses. So we're adding 2. That's pretty simple. And then we are raising it to the third power. So I just put parentheses, third power, just to indicate that we're raising to the third power. And then the last thing that we're doing is we're multiplying by 2. So I say multiply by 2. Now we need the inverses. So what's the opposite of adding 2? Subtracting 2. Simple. What's the opposite of raising something to the third power? Taking the third root of it. All right. And then what's the opposite of multiplying by 2? Obviously, it's dividing by 2. Now we're just going to reverse the order. So this is going to be first, this is going to be second, and this is going to be third. And we got y equals x. We always know that we're going to have x on one side and y should be by itself when we're done. So now all I'm going to do is do what the steps tell us to do? We're going to divide it by 2. So I'm dividing x by 2. Then we're going to take the cube root. And then let me kind of shorten this up a little bit. And then we're just going to subtract 2. And we are done. We are completely done with this. So we just have to write the inverse notation. And we're finished. All right, guys, I'm going to do one final example, and I'm going to step it up a little bit. I'm going to use something that has logarithm in it, but it's still the same process. So let's see, where is, yeah, here we go. All right, so I got y equals the log base 10 of x minus 8, and I want to find the inverse of this. I'm going to, again, stop the video, try it on your own, and then come back. All right, so here we go. First thing we're going to do is we're just going to swap the x and the y. Now, I'm going to go ahead and put the base 10 here so that you know that it has a base of 10. It's implied, but I wanted to make it explicit. Now, oops, I made a mistake here. That's supposed to be a y. So let me put a y minus 8, and now we're ready. Now, so we're going to use PEMDAS. And the first thing that we're going to do is what's inside the parentheses. So we're subtracting 8 from y. So you would say subtract 8. And then we're taking the log with the base 10. So I'm just going to put log base 10. There's nothing else that we're doing on this side. So now we're going to do the inverse. The inverse of subtracting 8 is adding 8. The inverse of the log with the base 10 is we're going to make a base of 10, and we're going to raise something to the, we're going to have a base of 10 and we're going to raise it. So the variable will be up there. All right. And we're going to reverse the order. This goes first, this goes second. We know that we're going to have, when we're done, y should be equal to some kind of x. And so now what we're going to do is we're just going to do the steps on that x. So what we're going to do is we're going to raise the x up and have a base of 10. So I'm going to write it like this. Okay. So 10 to the x power, that's the inverse of log of x with a base of 10. And then the last thing that we do is we just add 8. So we're going to add 8. And the 8 is not raised up. The 8 is basically down. All right. And that's it. That's the inverse. That's it. Let me see. Maybe I'll try one more here because that one was pretty quick. Let me see what we got over here. Yeah, I'll try this one. Yeah, this is y equals log of base 4, 3 to the x power. So let's stop the video, try this one, and then we'll do it together. All right. All right, so I'm going to rewrite it. Log base 4, 3 to the y power. And now I am going to use PEMDAS. So the very first thing that I'm doing to the x is I am raising it to the with the base of 3. So I'm saying 3 to some power. That's what I'm doing first. And then I'm taking the log with the base 4. Okay. So now I'm going to take the inverses, and the inverse of raising something to the 3rd power, or actually having a base of 3 and raising something to up there, would be to take the log with the base 3 of that something. And then the inverse of log with the base 4 is going to be 4, and we're going to raise something up there. Okay, so we're just doing the inverses, and we're going to reverse the order. We're going to do this first, we're going to do this second. So I come down here, I know it's going to be y equals x. And then the first thing I'm going to do is I'm going to raise it to the 4. Well, I have a base of 4 and I'm raising x, so I'm making it an exponential function with a base of 4. And then I'm just going to I need a little bit more room. I'm going to move this over. And then I'm just going to take the log of that. I'm going to take the log of this whole thing with the base of 3. So let me move this up a little bit. And what I'm also going to do, just to make this crystal clear, is I'm going to put this in parentheses. So that's the final answer. That's the inverse function. So that's it. I hope that you guys get this. I know that this went a little long, but I wanted to show you some examples, showing you how you would use PEMDAS. Then you do the inverse operations, and then you reverse the order. And then that's pretty much it. Once you've done that, it's just follow the steps. All right, guys, this is Mr. H. I'm signing off. If you have any questions, leave them in the comments, and I'll try to respond as quickly as possible. I hope this has been helpful. Have a good evening.